Okay, we'll continue on here. For acids, the naming system goes like this. If the anion ends in "ide," we change the anion name to hydroic acid. So here we have chloride that gets changed to hydrochloric acid. If the anion ends in "ate," we just use ic acid, no hydro prefix. And so here's phosphate, PO4 3 minus. This would be phosphoric acid. If the anion name's an "ite," here's nitrite. We just change the ending to "ous" acid, so this would be nitrous acid. Okay, so again, hydrochloric acid. This is phosphoric acid, and this one would be nitrous acid. Okay, going down here, this anion ends in "ate." This is perchlorate, ClO4, chlorate ClO3, minus charge. So this would be perchloric acid. This is chlorite down here, ClO2 minus. That would be chlorous acid. And this is bromite here, BrO2 minus. That would be bromous acid. Okay, then when we do the name here, the ic, that means it's 8, so nitrate. That's NO3 minus, so HNO3. This is hydroic, and so that means it's an "ide." This would be sulfide, which is S2 minus, that's H2S. This is hydroic acid, that's a "ide," so this is selenide, which is Se2 minus off the periodic table. This would be H2Se. This is a hydroic acid, so it would be iodide, that would be Hi here. And this is an ic acid, so it would be selenate. Selenate is like sulfate, it's SeO4 2 minus, so this would be H2SeO4 here. Okay, let's move on here to the next problem. Okay, the next problem is, let's go move this here. Shoot, let's try that again. Okay, I gotta shrink it down, sorry. Because this was offset, I don't know what's going on here. Alright, 31, that's what's next here. And what are the formulas of carbonate ion and selenate ion? Okay, the formula for carbonate, it's a 3 oxygen 8, and then borate's a 3 minus, so carbonate would be a 2 minus, so CO3 2 minus. And then selenite, so we got to figure out what selenate is. Selenate is a 4 oxygen, has the same charge as sulfate, and so it'd be SeO4, and the charges go silicates 4, and then phosphates 3, sulfates 2, so selenate would be an SeO4 2 minus, and therefore selenite would be an SeO3 2 minus. What is the name of BrO3 minus? Well, it's in the 3 oxygen block, and it's bromate, and it has a -1 charge. So we could check the answers here. CO3 2 minus, SeO3 2 minus, and bromate ion. What is the formula of arsenate? So arsenate's right below phosphate. Phosphate's a PO4 3 minus, so arsenate would be ASO4 3 minus. What are the names of TeO3 2 minus? Well, tellurium, Te is in the 4 oxygen block, so that would be TeO4 2 minus would be tellurate, so this must be tellurite. And then IO3 minus. IO3, that's in the 3 oxygen block, and so that would be iodate. So tellurite and iodate. What is the formula of sodium tellurate? Well, tellurate is TeO4 2 minus, so sodium is a +1, so we need 2 sodiums, Na2, and then 1 tellurate, TeO4. So Na2TeO4. What are the names of MgBrO taken twice? Okay, so BrO, well, bromate's BrO3, 3 oxygen with a minus, so bromite would be BrO2, and so this must be hypobromite, BrO. So this would be magnesium hypobromite. Again, we don't use the di prefix, so we only use the ditri for binary molecular compounds. This is not. Okay. And then FePO4. Okay, PO4, we know that. That's a 3 minus. That's phosphate. So this must be iron 3. Iron's a 2-3. And so this is iron 3, Roman numerals in parentheses, phosphate, or ferric phosphate. So here we have the Ne2TeO4, magnesium hypobromite, and iron, Roman numeral 3, parentheses, phosphate. What are the formulas of zinc nitrate and calcium selenate? Okay, zinc nitrate, zinc, Zn, is fixed charge, it's +2. So we need 1 zinc, and nitrate, NO3 minus. So we need 2 nitrates. So Zn, parentheses, NO3, parentheses, 2. Calcium selenate. Okay, calcium is a fixed charge at 2+. Selenate is a 4 oxygen, SeO4, with a charge 2-. And so we'd need 1 of each. So it would be Ca, SeO4. What is the name of this? Okay, NH4 NH4 is ion polyatomic. It's one of the ones you should memorize. It's called ammonium NH4 plus. It's got a 1+ charge. And then BrO2. BrO3 is bromate, so BrO2 must be bromite. So this is ammonium bromite. Be the name of that one. Okay, let's move on to next here. All right, explain how an anion can behave like an acid. Is it possible for a cation to be an acid? Okay, an anion can be an acid, yes. Well, acids, I didn't talk about this, but acids have to have a high H, and the H has to be, well, we'll get into what an acid is in more detail later, but usually acids begin with an H. And so we had the hydrogen carbonate ion, or bicarbonate, HCO3 minus, and others. Is it possible for a cation to be an acid? It is possible for a cation to be an acid. Ammonium is an example of that, NH4 plus. However, it didn't begin with an H, and we'll look at acids in much more detail. So an anion contains cation that contains an ionizable hydrogen, such as HSO4 minus, and ammonium can release the hydrogen ion to a water molecule and thus behave as an acid. That's correct. So ammonium, where that hydrogen ion comes from is, if you take ammonia, NH3, and add an H+, you'll form NH4+. If you take sulfate and then an H+, we'll get HSO4-. So that's what they have in common. And both of them can lose that. So for example, if hydrogen sulfate or bisulfate loses that hydrogen ion, we're left with H+ and sulfate. If ammonium loses that H+, then we are left with NH3 and H+. And so that's what they mean by an ionizable hydrogen. It can be lost. It can be formed in that way of gaining an ionizable hydrogen, or a hydrogen ion, I should say, and it can be lost by doing that. An unionizable hydrogen would be something like in acetic acid. For example, acetic acid is HC2H3O2. The H3 part of that is unionizable, so that's why they write the 2 hydrogens separate, 2 types of hydrogens separate, an H and the C2H3. Those hydrogens aren't the same, and we'll see that structurally later. Okay, write equations for the first and second steps in the step-by-step ionization of selenic acid. All right, so maybe I should just show you HC2H3O2. So I'll just show you the structure really quick of this. For acetic acid, the structure for where those hydrogens are at are a bit different. So for example, here you can see that the hydrogens are different. We have 3 hydrogens bonded to a carbon and 1 hydrogen bonded to the oxygen in acetic acid. For the step-by-step ionization of selenic acid, okay, selenic acid is selenate. Selenate is SeO4 2-. So selenic acid would be H2SeO4. This would be the formula here for selenic acid. And then what they're saying by the step-by-step ionization is just losing a hydrogen each time. So if we lose 1 hydrogen, we form H+ plus SeO4 HSeO4, sorry, plus HSeO4 minus. You can see that here. Okay, then the HSeO4 minus in turn can lose another hydrogen. And so it will form H plus SeO4 2 minus. And so this would be the two steps in the step-by-step ionization of the selenic acid molecule here. Okay, let's continue on here. Hydrogen sulfide ion. Hydrogen sulfide is to take a sulfide ion, and so we've got to look at sulfate. Sulfate is 4 oxygen, SO4 2 minus, so sulfide would be 3 oxygens, SO3 2 minus. And so hydrogen sulfide ion would be HSO3 minus 1. And then hydrogen carbonate, again, you just take carbonate, CO3 2 minus, and add a H plus. So we form HCO3 with a -1 charge because the H plus neutralizes one of the negative charges on carbonate. So that's what we have here. Dihydrogen phosphate ion. Okay, dihydrogen phosphate. Phosphate can, as we saw, I think in class, phosphate is a 3 minus. So we could actually put more than 1 and still have a negative charge. And so that would be H2PO4 minus, would be dihydrogen. There's no such thing as trihydrogen phosphate ion because trihydrogen would neutralize that and that would form phosphoric acid. Okay, hydrogen sulfate is just take a sulfate, SO4 2 minus, add an H plus, we get HSO4, we could change the charge to -1. HSO4 -1. Tellurite, okay, tellurate is 4 oxygen, TeO4 2 minus. Tellurite must be 3 oxygen, so TeO3 2 minus, so H2TeO3, H2TeO3. Let me write that down, TeO3 here. That's what we'd have here. Oops, there we go. And then that's wrong, actually. This is not hydrogen tellurite, because this would be tellurous acid, it's neutral. Hydrogen tellurite would be just 1 hydrogen on there and a TeO3 with a negative charge because there's tellurate. Tellurate is TeO3 with a 2 minus charge, so hydrogen tellurite. Tellurite. Actually, let me get this TeO3 2 minus. Okay, let me start over there. TeO3 2 minus is tellurite. Hydrogen tellurite would be HTeO3 minus, and since it's tellurite, this would be tellurous acid, H2TeO3. Let's continue on here. HSeO3 minus, okay. SeO4 2 minus is selenate, so this must be selenite here, and that must be hydrogen selenite ion. And this is a telluride, Te2 minus is telluride with an IDE. So this is going to be the hydrogen telluride ion. Okay, that's what we got there. And then HCO3 minus is hydrogen carbonate or bicarbonate. HTeO4, okay, TeO4 2 minus is a tellurate, so this is hydrogen tellurate. And then SO3 2 minus is sulfite. Sulfate's SO4. And this is hydrogen sulfite here. Let's continue on here. I gotta go forward here if I can. Come on. Okay, let's go forward here. There we go. Alright, let's see. Let's go to the top here. Among the following, identify all hydrates. Okay, I didn't talk about hydrates yet, but we'll talk about it now. Sometimes what can happen in the crystal lattices is that waters can get trapped in the void spaces between the ions. Sometimes we could fit waters here, or waters can interact with it. So waters get incorporated into this crystal structure, or crystal lattice itself. In this case, 6 waters for every nickel and sulfate unit. We call it a formula unit. 6 waters for every formula unit. That is 1 nickel ion and 1 sulfate ion can get trapped in there. And so naming hydrates is pretty simple. It's just nickel sulfate dot or nickel sulfate hexahydrate or 6-hydrate. So nickel sulfate 6-hydrate or nickel sulfate hexahydrate. Okay, this would be potassium chloride. There's no waters getting trapped in there. Now, this is not wet. This is still a solid. The nickel sulfate still looks like a solid. Sometimes the color does change on the hydrated form versus the anhydrous form. This is anhydrous potassium chloride or just potassium chloride. Okay, this is sodium phosphate dot 12-hydrate. Let's see what they got here. So hydrates. Oh, what are the hydrates? Okay. Well, obviously, these two are hydrates. The sodium phosphate is still a solid, and the anhydrous is KCl. It is often possible to change a hydrate into an anhydrous compound by heating it to drive the water, in other words, dehydrate it. Write an equation that shows the dehydration of potassium fluoride dihydrate. Alright, so if we do potassium fluoride, potassium ion is K plus, fluoride's F minus, so we just need one of each. K dihydrate would be two waters, and again, this is a solid. And so we'd have something like this, KF dot two waters solid. Okay, to show an equation dehydrating it, we heat it. Okay, and so heat is usually given the symbol delta. And so that would give us KF plus 2H2O. Okay, the H2O, we can drive it off as a gas, like something like this, H2O gas, heat here. And so you can see this, let's just take a look online here. For example, copper sulfate. Copper sulfate, we look at the hydrate and the anhydrous form of that anhydrous. And let's take a look at some images of that. Here you can see here on the left, this, oops, sorry. Okay, on the left here, you can see the hydrated form of the crystals, and here you can see the dried out, or the anhydrous. So this is CuSO4, this is CuSO4 dot 5H2O. And so the waters get actually incorporated. It's not a liquid, these are just waters get incorporated in the solid on the left there. And the water's not on the surface. The crystals do not look wet in the sense that they're watery. Here you can see they're adding some water to that. And the water gets soaked up like a sponge. Okay, let's continue on here with this. Epsom salt has the formula MgSO4 dot 7H2O. How many water molecules are associated with one formula unit of magnesium sulfate? So the formula unit again is just one magnesium, one sulfate. And we got 7 waters there. Write the chemical name of Epsom salt. Epsom salt is magnesium sulfate dot 7-hydrate. So you would write out that, and so it'd be just magnesium sulfate, and then 7 you could use heptahydrate if you want, or just 7-hydrate, heptahydrate. So magnesium sulfate heptahydrate would be it. So let's say what they did here. Magnesium sulfate heptahydrate. Okay, how many water molecules are associated with one formula unit of calcium chloride in this? Okay, if we look at one unit of CaCl2, we have 2 waters. Write the name of this compound. So this would be calcium chloride. Again, we don't use the dye because it's an ionic compound. So calcium chloride. And then here we have to use the dye, dihydrate. But we don't use the dye in calcium. We don't call it calcium dichloride, dihydrate. We call it calcium chloride, name it as normal ionic compound, and then the dye with water, because we can't tell how many waters there are. The amount of waters depends on the crystal lattice itself and how we can fit those waters in. So you see different amounts of water. For magnesium sulfate, we saw 7. For copper 2 sulfate, we see 5, and that is just from experimentation. You can figure out how many waters there are. Write the formulas of ammonium phosphate trihydrate. So ammonium is a +1, phosphate's a -3, so we need 3 ammoniums for every phosphate. So parentheses NH4, parentheses 3 PO4. Now trihydrate has 3 waters, so it would be dot 3 H2O. That would be that. Potassium sulfide. Sulfide is a S2 minus. Potassium is +1, so it would be K2S pentahydrate. And so we put a dot 5 H2O. So here we have NH4 3 PO4 dot 3 H2O K2S dot 5 H2O. Okay, the compound barium perchlorate forms a hydrate with 3 water molecules per formula unit. What is the name of the hydrate? So barium perchlorate trihydrate would be the name. What is this formula? BaClO4. BaClO4 dot 3 H2O. Be its formula, and again it's barium perchlorate. Because chlorate is a 3 oxygen, so perchlorate would be a 4 oxygen trihydrate. Okay, so we end up with something like this: barium perchlorate trihydrate, and the formula BaClO4 3H2O. Let's move on here. It's number 46. Okay, come on. There we go. Ooh, okay, this is quite a lot. In each box, write the chemical formula of the compound formed by the cation at the head of the column and the anion to the left of the row. Refer only to a clean periodic table when completing this exercise. Okay, yeah, you don't want to. You want to have the ions memorized, but let's go ahead and write them down. Nitrate is 3 oxygen, and it goes borate 3, carbonate 2, nitrate 1, so NO3 minus. Sulfate's a 4 oxygen, and we go silicates 4, phosphates 3, sulfate is 2, so SO4 2 minus. Hypochlorite, okay, chlorate. First we get chlorate. Chlorate's 3 oxygen, ClO3 minus. Chlorite, 2 oxygens. Hypochlorite, 1 oxygen. And so this would be HClO minus. Nitride, okay, well, we go with fluoride as a -1, oxide's a -2, nitride's a -3, so N3 minus. Hydrogen sulfide. Now, this is hydrogen sulfide ion versus hydrogen sulfide compound. The nomenclature, the name is the same, and so we must use the word ion for this. And so here we have H2S gas, for example, and here we have HS minus. We don't want to name these two the same thing, but they are named the same thing. And so H2S gas is hydrogen sulfide gas, HS minus is hydrogen sulfide ion. And so, unfortunately, the names are duplicate there. Unless we name it hydrosulfuric acid, which is one option there. Okay, bromide. Bromite's in the 3 oxygen, that would be BrO3, and the charge is -1. And so potassium is +1. So potassium nitrate is KNO3, this 1-to-1 ratio, KNO3. Calcium is a 2+, so we'll need 2 nitrates, so Ca parentheses NO3 twice. Ca parentheses NO3 twice. Chromium 3 is a 3+, and so Cr, and then we'll need 3 nitrates there. And so Cr parentheses NO3 3 times. There we go. Zinc is a 2+, fixed charge. It's one of those fixed charge ones. I'll need 2 nitrates for that here. Silver is +1, fixed charge, so AgNO3 should be that one. Okay, sulfate is 2-, potassium is +1. We'll need 2 potassiums, K2SO4. Calcium is a 2+, sulfate's a 2-, so 1-to-1 works. CaSO4. Chromium is 3+. And so actually in this case we'll need 3 sulfates and 2 chromiums. So Cr2 and then parentheses SO4 3. Cr2 parentheses SO4 3. Zinc is a 2+, sulfate's a 2-, so 1-to-1 works. ZnSO4. Silver is a +1, sulfate's a -2, so we'll need 2 silvers. Ag2SO4. we move on to potassium hypochlorite. Okay, potassium hypochlorite, K is a +1, hypochlorite is a minus, and so this would be KClO. KClO. Here we go. Calcium 2 plus, hypochlorite minus. So we need 2 hypochlorites. CaClO parentheses 2. CaClO parentheses 2. Chromium 3 hypochlorite. So 3 hypochlorites we'll need. So it'll be like the nitrate up there. Let's put the 3 hypochlorites in the parentheses like this. Zinc is a 2 plus, hypochlorites minus, so we'll need 2 hypochlorites here. So we got the ZnClO. Silver is +1, so 1 hypochlorite, 1 silver. 1 hypochlorite, 1 silver. AgClO. Okay, nitrites are 3 minus, potassium is +1, so 3 potassiums. K3N. Calcium is a +2, nitrites a minus. And so we could do the cross trick. That is the 2 ways we can figure that out. Calcium is 2 plus, nitrites 3 minus, so we can bring down the charges to use as a subscript. So we get Ca3 and 2. So we could use this trick and just make sure it's at the simplest ratio, which 3 to 2 would be. So Ca3 and 2. Or we could just count out the ions and see what point they neutralize each other charge-wise. Chromium is 3, nitrites are 3, so 1-to-1 works here. Can, or excuse me, not Ca. Ca is calcium. Cr and Cr is chromium. Zinc is a 2, nitrites a 3, and so this would be the same as over here, except it would be Zn3 and 2. Zn3 and 2. And silver is +1, so we need 3 silvers. Ag3 and G3 and. Okay, the hydrogen sulfide's a -1, so potassium +1, so KHS. Calcium, we'll need 2 HS's, and so this will be KHS taken twice. KHS taken twice. Chromium 3, we'll need 3 HS's. That. Zinc is a 2 plus, we'll need 2 HS's. Silver is a +1, we just need 1. GHS. Okay, bromite, BrO2 minus KBrO2, be this one. Oops. Alright, it's not working for some reason. Okay. Is that not working? Well, anyway, I can't see the answer here. Oh, I see why, because I have to extend this thing. This is a long one. Now I gotta move this over here. Okay, this would be KBrO2. KBrO2. This is calcium. We need 2 of the BrO2 minus. We have 2 of the BrO2s. Chromium is 3 plus. We'll need 3 bromides here. Zinc is a 2 plus. We'll need 2 of the bromides here. Okay, I need to scroll over here, so I can't blow this out. Silver is +1, so just 1 bromide. It'll be AgBrO2. Oops. Didn't fill the rest of this table out, did I? Okay, we'll come back to those. Okay, hydrogen phosphate. Okay, there are actually, to avoid confusion here, which hydrogen phosphate, because we start off with phosphate. And then we have something like hydrogen phosphate and dihydrogen phosphate, and then phosphoric acid. Depending on how many H pluses we add here. So phosphate, the first one you could call monohydrogen, the second one you could call dihydrogen, the third one you can't call trihydrogen, the third one's phosphoric acid, it's neutral. And so we have 2 acid anions. To avoid confusion, call the first one monohydrogen or hydrogen phosphate, and the second one's got to be dihydrogen phosphate. So your book is going to use hydrogen phosphate. The Chem 1A book uses monohydrogen phosphate, which would be a 2 minus. And so potassium, we need 2 potassiums, K2HPO4. Calcium is 2 plus, so 2 minus, 2 plus, and 1-to-1, so CaHPO4. Chromium's 3, so we would need, this is 2 minus, so we need 3 hydrogen phosphates for every chromium. So for every 2 chromiums. So Cr2, HPO4, 3. Zinc is a 2, so the same thing. Zn2, HPO4. Oops. Excuse me, same charge is what I meant. Silver is the +1 Ag HPO4. So we need 2 Ags, Ag2 HPO4. Sorry, 2 HPO4. Okay, continuing on, chloride is -1 potassium KCl. Okay, then we got calcium. Actually, I'm running short on time. Calcium chloride was CaCl2. Chromium is a 3 chloride. We need 3 chlorides here. That would be CrCl3. Zinc is a 2, so 2 chlorides. ZnCl2 here. Silver is a 1, so just 1 chloride. AgCl. Silver chloride there. Alright, potassium carbonate, or excuse me, hydrogen carbonate. And now here, there's only 1, so it's HCO3 minus, because H2CO3 would be carbonic acid. So HCO3 minus, so this is KHCO3. Calcium is 2+, so we need 2 bicarbonates. Chromium is 3+, so only 3 bicarbonates. Zinc is a 2+, 2 bicarbonates should do it. And then silver is a plus, so 1 bicarbonate should do it here. Okay, and I didn't get to these, I didn't scroll over. So iron's a 3, we'll need 3 nitrates. We'll just go down the column this time around. Iron's 3, so the sulfate's a 2. And so 2 iron 3s, and then 3 sulfates. 2 iron 3s, 3 sulfates. Okay, iron's a 3, hypochlorite is a 1, so 3 hypochlorites for every iron. 3 hypochlorites for every iron. Iron's 3, nitride's a 3, so it's just 1 to 1, Fen. Okay, iron's a 3, HS is -1, so 3 of those, so Fe with 3 HS's. With 3 HS's. Hypobromite, no, this is not hypobromite, this is bromite. Hypobromite is BRO. So bromite, we'll need 3 of those, and so Fe parentheses BRO 2, 3. Okay, and then monohydrogen phosphate or hydrogen phosphate is a 2 minus, and so we're going to do the ratio. 3 of these hydrogen phosphates and 2 of the iron, so Fe2 HPO4 taken 3. Okay, chloride's 3, so just FeCl3 should do this. And then bicarbonates, or hydrogen carbonates, a 1, so 3 of those. We'll need 3 bicarbonates for every iron. 3 bicarbonates for every iron. Okay, again, the cation always goes first and followed by the anion. Okay, aluminum's a 3+, so nitrates 3 and -1, so 3 nitrates for every aluminum. Okay, aluminum's 3+, so it's the same thing. It's 3. We're going to get Al2SO4 3 here. Aluminum's 3+, so we'll need 3 of the hypochlorites. 1 to 1 should work here. 3 of the HS minuses, like this. And 3 of the bromites. 3 of the monohydrogen phosphates. 3 chlorides, LCl3. Aluminum's fixed charge, whereas iron's variable charge. And 3 bicarbonates should do this here. Aluminum bicarbonate or aluminum hydrogen carbonate would be the name there. Okay, mercury 1. Mercury 1 is Hg2, 2+. It's a diatomic ion. So Hg2, 2+, so it's a 2+. If it's 2+, it's like zinc over here. Except we do Hg2, and then we would have to do the parentheses, NO3, taken twice. So Hg2, we can't simplify this to 1 to 1 here, because it's a diatomic ion. And so it's 2-2 ratio, we gotta leave it as 2-2. we can't simplify it to 1, 1 again. Okay, here, sulfate is a 2 minus, so it'd just be Hg2SO4. Hypochloride's a -1, so we'll need 2 of those. So again, it's a 2-2 ratio here, which can't be simplified. Here, HS is -1, so it's going to be 2 HS's, like that, for every Hg2. Hg2 again is fixed. For every Hg2, we're going to need 2 bromides. Hg2 will need 2 bromides. Hydrogen phosphate is a 2 minus. It works out. It'll be just Hg2 HSO4, or excuse me, HPO4, and then chloride's -1. So Hg2 Cl2. So again, this is a 2-2 ratio, which we can't simplify into 1-to-1 ratio. And bicarbonate's -1, so we'll need 2 bicarbonates. Hg2. There we go. All right, so that's that. All right, let's see here. So 49. Let's continue on here. Calcium hydroxide. Okay, hydroxide, we have to memorize that one. That's one of the ides that aren't monatomic. So there are certain ides, hydroxide, peroxide, and cyanide are the 3 important ones that aren't off the periodic table. But normally, if it's an IDE, we just get it off the periodic table. We get the charge off the periodic table. That is, it's just monatomic, 1 atom. Hydroxide's polyatomic. It's an ide. So OH minus, calcium is a 2 plus, so Ca with 2 hydroxides, Ca parentheses OH2. Ammonium is NH4 plus, and bromide is a monatomic ide, Br minus, so NH4Br should work 1-to-1. Potassium is +1, sulfate is polyatomic, 8SO4, the charge would be 2 minus, so K2SO4. Those. Okay, barium nitrite. Okay, nitrite is a 3 oxygen, and charge is minus, so nitrite will be 2 oxygen, NO2 minus. Barium is a 2 plus, so BaNO2 taken twice. Okay, and then we have sodium hydrogen carbonate. So, what is? Oh, we'll just do. Here's sodium nitrite, sodium hydrogen carbonate. Okay. Hydrogen carbonate is HCO3 with a -1, so sodium hydrogen carbonate would be just NaHCO3, like this. Okay, sodium sulfate. Sulfate is SO4 2-, so sodium sulfate is going to be Na2SO4, like that, Na2SO4. And then finally, calcium sulfide. Sulfide is a 2-, calcium is 2 plus, so just CaS. It's a 1-to-1. 2 plus and 2 minus balance each other out. I just skipped, I just see where I misread this. Okay. These ones had the answers. Okay, aluminum nitrate. Aluminum nitrate. Aluminum's fixed charge, 3 plus. We'll need 3 nitrates to that. So let me just write AlNO3, taken 3 times. That'll be it here. Calcium chromate. Okay, chromate you just have to memorize. Well, that's not off the periodic table. And so chromate is a CrO4 2-. CrO4 2-, just straight memorization. Calcium is 2 plus. We can get that off the periodic table. CaCrO4, they balance 1-to-1. Okay, magnesium is 2 plus. Oxide is a 2-, so it's just MgO 1-to-1. Aluminum phosphate. Aluminum is 3 plus. Phosphate is 3-. That's a 1-to-1. So AlPO4. We did sodium sulfate and calcium sulfide already. Aluminum bromide. Bromide is a BrO2. Bromate's BrO3. And the charge is -1, so we'll need AlBrO2. BrO2 will taken 3 times. So we get something like that. Okay, chromium 3 oxide. Oh, actually, I'm doing it again. Potassium dichromate. Okay, I expect you to memorize dichromate. It's not going to be given. It's a Cr2O7, 2-, so you're just going to have to memorize it. I don't know why they give it to you in the book here. This is 2 minus, so we'll need 2 potassiums, K2Cr2O7. Okay, no charge on that. K2Cr2O7, potassium dichromate here. Okay, barium dihydrogen phosphate. Okay, dihydrogen phosphate is a 1 minus. So we'll need 2 of these dihydrogen phosphates for every barium, because barium is 2 plus, so it's going to look like this. Rubidium selenate. Okay, selenate, SeO4, so 4 oxygen block, and the charge would be 2 minus. So rubidium is a plus 1, so we need 2 rubidiums for every selenate. RbSeO4. Okay, barium sulfite. Sulfate is SO4. Sulfite would be SO3. Charge is 2 minus. So barium, Ba is a 2 plus. BaSO3. Chromium 3 oxide. Chromium is 3. Oxide is 2. So we'll need 2 chromiums for every 3 oxides. So Cr2O3. Potassium periodate. Okay, iodate is IO3 minus, periodate would be IO4 minus. So 1 minus charge, so potassium is 1 plus, okay, IO4. We have calcium hydrogen phosphate, so again this is a monohydrogen, so the Ca, we need 2 hydrogen phosphates for every calcium, Ca parentheses H, PO4, 2. Okay, they made a mistake here. This is not, oops, sorry, I made a mistake here. HPO4 is, again, HPO4 is a 2 minus, so, sorry. It's dihydrogen phosphate is the 1 minus. So I need to, I need to start calling monohydrogen and dihydrogen phosphate, otherwise I get confused sometimes. It would be calcium monohydrogen phosphate, which would be a 2 minus charge. Okay, cobalt 2 hydroxide. So COOH2 hydroxide is a 1 minus. Zinc chloride, ZnCl2, chloride is a 1 minus. Lead 2 nitrate, nitrate's a 1 minus. So PbNO3 twice. Copper 1 nitrate. Copper is a plus 1, nitrate's a minus 1, so 1 to 1. CuNO3 would be the formula for that. Can you each box write the formula? Okay, this will be sodium hydroxide. Okay, this is, what is this? Mercury 1 hydroxide. This is ammonium hydroxide. This is lead. Lead is a 2,4. Mercury is a 1,2. Sorry, this is mercury 2 hydroxide. Mercury 2 hydroxide. Lead is a 2,4. This will be lead 2 hydroxide, or plumas. Magnesium is 2 plus. Magnesium hydroxide. Let's see, which way should we do this? Maybe we'll just go down. We'll go down the columns here, it'll be easiest. So sodium hydroxide. Sodium, what's the name of this one? This would be bromate is BrO3, so bromide's BrO2, hypobromide's BrO. So this would be sodium hypobromite, sodium carbonate, sodium chlorate. So let's look at those. Sodium hydroxide, sodium hypobromite, sodium carbonate, sodium chlorate, sodium hydrogen sulfate, or sodium bisulfate is another name for that. Sodium bromide, sodium phosphate. Looks like I'm going to run out of space here. Let's collapse these down so I don't run out of space. Sodium, okay, iodate's IO3, so this must be periodate, sodium periodate. Again, we don't use any kind of a di or tri to indicate. We know how many ions we'll need. For example, we need 3 sodiums to balance each phosphate, so we still call it sodium phosphate, not trisodium phosphate, although in laundry detergent you might see trisodium phosphate to avoid confusion. This is sulfide, so this is sodium sulfide. That's the last one. Here we can figure out we need 2 sodiums for every sulfide based on the charge, so we don't need di. We can just call it sodium sulfide. Make the answer more compact, so let's collapse those. Same thing, this would be mercury 2 hydroxide, mercury 2 hypobromite, mercury 2, and when I say mercury 2, it's parentheses, Roman numeral 2, close parentheses. Mercury 2 carbonate, mercury 2 chlorate, mercury 2 hydrogen sulfate, mercury 2 bromide, mercury 2 phosphate, mercury 2 periodate. Let's just collapse one of these, and then mercury 2 sulfide. Mercury 2 sulfide. Let's collapse all these. Ammonium hydroxide, ammonium hypobromite, ammonium carbonate, ammonium chlorate, ammonium hydrogen sulfate, ammonium bromide, ammonium phosphate, ammonium periodate, and ammonium sulfide. Those would be the names. Actually, these will have the answers in the book too, so you can just see these in the book. Okay, and then continuing, lead 2 hydroxide. What's going on there? Okay, I'm offset by one here. Lead 2 hydroxide, lead 2 hypobromite, lead 2 carbonate. Okay, now let me scribble over here. Actually, I'll just do this here so we can see what anion we're dealing with here. Horizon. So lead 2 chlorate, lead 2 hydrogen sulfate, lead 2 bromide, lead 2 phosphate, lead 2 periodate, and lead 2 sulfide. Okay, iron's a 2,3. There's iron 3, so iron 3 hydroxide. Oops, sorry, over here, magnesium 2, that's fixed charge, magnesium 2 hydroxide. No, we don't need the Roman numeral. Magnesium hydroxide, magnesium hypobromite, magnesium carbonate, magnesium chlorate, magnesium hydrogen sulfate, magnesium bromide, magnesium phosphate, magnesium periodate, and finally magnesium sulfide. Be the last one there. Okay, iron 3 is next. Iron 3 hydroxide. Just close those down. So iron 3 hypobromite, iron 3 carbonate, iron 3 chlorate, iron 3 hydrogen sulfate, iron 3 bromide, iron 3 phosphate, iron 3 periodate, iron 3 sulfide, and finally copper. Copper is a 1,2. So these are all going to be the same thing except with copper 2 instead. So copper 2 hydroxide, copper 2 hypobromite, copper 2 carbonate. Let's scroll over here. Copper 2 chlorate, copper 2 hydrogen sulfate, copper 2 bromide, copper 2 phosphate, copper 2 periodate, and copper 2 sulfide. And those are those here. Okay, let's close that so we finish that. Alright, let's continue on here. Write the name. So this is lithium, this is phosphate, so lithium phosphate. This is magnesium ion, Mg2+. This would be magnesium carbonate. This is barium ion and nitrate, so it's barium nitrate. Okay, this is lead 2 ion and sulfide ion, S2 minus, lead 2 sulfide. Silver is fixed charge, +1, silver and the hydroxide, silver hydroxide. This is cobalt. Cobalt's variable charge, 2,3. So this is cobalt 3 bromide. Cobalt Roman numeral 3 parentheses bromide. This is potassium with fluoride, potassium fluoride, sodium hydroxide, calcium iodide, and aluminum carbonate. This is magnesium hydroxide, sodium carbonate, silver nitrite, and then cobalt. Cobalt's variable charge. You'll see the charge on cobalt's 2, charge on phosphate's 3. So this is a cobalt, Roman numeral 2, phosphate, it's a 2,3. Copper is variable charge, 1, 2. So this is copper 2, I can tell because the sulfate's a -2. So this is copper 2 sulfate. And then we have chromium's variable charge, 2, 3. This is chromium in the 3 because hydroxide's a 3. minus, and you got 3 of those. So 3 minus is negative 3 charge. So chromium 3 hydroxide. Mercury, we have 2. It's a 1, 2. This is going to be mercury 2, 2 plus, which is actually called mercury 1. So this is mercury 1 iodide here. And so we got those. This is bromate, BrO3 minus 1. So barium bromate. This is oxalate, C2O4, 2 minus. Again, oxalate you have to memorize. K2C2O4. This is the, this is tellurate. So this would be hydrogen tellurate. So this would be aluminum hydrogen tellurate. Okay. This would be selenate, it's SeO4, it's in the 4 oxygen box. So this would be selenite, potassium selenite would be that one. In each box, given the formula, give the name. Okay, let's try these out. Here. Expand it here. Let's scroll over. Okay, so formula. This would be hydroxide ion. This would be lead 2 oxide. Oxide's minus 2, so the lead's a 2,4, so there's 1 lead 2 oxide. This would be sulfate ion, so 2 minus. This would be chlorine, elemental chlorine, Cl2. This would be, this is a binary molecular compound, 2 nonmetals, so dichlorine monoxide. Okay, chromium is a 2,3. This is going to be chromium 3 plus, because this is perchlorate, chlorate ClO3, perchlorate ClO4 minus 3 of those. So chromium, Roman numeral 3, perchlorate. Okay, this is acid ion. This would be dihydrogen phosphate ion. Okay, aluminum's fixed charge, so aluminum and sulfide, aluminum sulfide. Copper and sulfate. Copper is variable, so this is copper 2 sulfate. Sulfate's a minus 2, fixed charged. HF, fluorine's a fixed charge, minus 1. H is plus 1 in this case. Hydrogen fluoride, it's aqueous, so we're not going to call it hydrogen fluoride, we're going to call it hydrofluoric acid. You know, the I gets changed to hydrofluoric acid. This is just elemental carbon. It's carbon. Okay, let's move down the list here. Let's collapse some of these here. Let's see what's we got here. Sodium bromide, Ne is plus, Br is minus, NeBr. Ammonium is NH4 plus, phosphates 3 minus, PO4 3 minus. So you need 3 ammoniums for every phosphate. 3 ammoniums for every. Bromine's elemental, Br2, it's diatomic. Hydrogen phosphate ion. Okay, this is a monohydrogen, so HPO4 with a 2 minus. Nitrite is nitrate's 3, NO3, nitrite, NO2, charge minus 1. Iron 3 phosphate. Okay, iron 3 is 3 plus, phosphate's 3 minus, FePO4. Nickel is 2, sulfide's at 2 minus, so NiS. Nitrogen elemental N2. Copper 2 bromide, 2 plus, bromide's minus, 2 bromides. CuBr2. Oxygen difluoride, binary molecular compound. OF2. Potassium ion, K plus, fixed charge. Alright, that was 61. Okay, now do one more. In each box, when given a formula, write the name. Given the name, write the formula. Okay. Refer to nothing. Okay. Except the periodic table. Of course, we will refer to the periodic table. Okay, SeO4 2 minus. Sulfate's SO4. This would be selenate. Selenate ion. Hydrogen carbonate or bicarbonate, we've seen that before. Neon element. This is binary molecular, and 2 nitrogens, and that's at 5 oxygens. Dinitrogen pentoxide. 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 This is a nitrite, this is an acid. So nitrite and nitrate is NO3, minus nitrites NO2. This is nitrous acid. This is binary molecular compound, carbon tetraiodide. This is not barium dihydride, this is barium, and then the anion here is hydride, H minus, so we need two of those. So this is barium hydride. Tellurate is TeO4, that must mean this is tellurite, so this is calcium tellurate. Okay, this is another acid, this is hypobromite. Hypobromite, bromate is BrO3, bromite's BrO2, hypobromite's BrO. So this is hypobromous acid. Ike gets changed to house acid. This is nitrate, iron must be +2, so this is iron 2 nitrate. This is magnesium sulfate dot heptahydrate, or magnesium sulfate heptahydrate. Okay, gallium is, we look on the periodic table, where's gallium? Gallium is below aluminum, so it should be a 3+. Sulfate's a 2-, so that would be, gallium would be Ga2SO4 3 parentheses around the SO4. Perchloric acid. Perchloric would be a perchlorate. It's just ClO3 is chlorate, so perchlorate ClO4 with a minus charge, so it's HClO4 perchloric acid. Lithium is the element Li. Cobalt 2 chloride hexahydrate. So it's cobalt's a 2, chloride's -1, so COCl2 dot 7 or 6 hexa 6.6 H2O. Barium dihydrogen phosphate. PA is 2+ dihydrogen phosphate, so 1-, so we'll need 2 dihydrogen phosphates for every barium. Ba parentheses H2PO4 taken twice. Hydrosulfuric acid. Hydro, ig means ide, so sulfide. Sulfide's S2-, so hydrosulfuric acid is H2S, aka hydrogen sulfide. H2S. We might write H2SAQ just to emphasize that point. H2SAQ here. Okay, magnesium nitride. Nitride's a -3, so magnesium's +2. So 3 magnesiums, Mg3 for 2 nitrides, and Mg3 N2 would be it. Ic acid. Ic acid is 8. There's no hydro, so it's selenate. Selenate is SeO4 2-. Selenate, and then we just add the hydrogens to that, and so it'd be H2 SeO4 to balance out the charge. H2 SeO4 selenic acid. Okay, let's continue on here. I don't think I scrolled down on the other side, did I? Calcium sulfite. Sulfite's Sulfate's SO4, so sulfite's SO3, 2- charge. So CaSO3. Hydride, -1. NaH. Chloride is -1. Mercury 1 is Hg2, 2+, so Hg2Cl2. Yeah. Okay, well, I gotta stop here at number 62. Let's see, we've got quite a few more to do here, so I'm gonna go ahead and pause this or stop here.